G'day everyone, welcome to another episode of Python for LEGO Spike Prime. Today we're going to use conditionals to turn you into a Jedi Master. G'day, my name is Gary, and if you haven't been following these lessons, then make sure you check out the last video over here, just so that you are up to speed and learn the basics before we go on to this video, because each video builds on top of each other. It would be really good to make sure that you have followed and understand all the lessons before you do this one. So today we're going to look at conditionals. Conditionals is essential for artificial intelligence because a robot needs to be able to make decisions by itself. How does it make decisions? It does it through conditionals. In Scratch, these conditionals come in the form of operators, and in Python, they're very, very similar. So we will start off with some basic activities just to get the hang of some of your conditionals before we move on to the fun stuff and turn you into a Jedi. So let's get started. First of all, make sure you open Spike Prime. And then we start a new project. And of course, we have the driving base 2 built from the previous lesson as well. So start a new project. Make sure you choose Python. And then we kind of call this CA Python conditionals. And then go create. Let's hide the helper. All right, so let's do our organization here. So create objects here and execute code here. And then we're going to define our robot. So make sure you remember where all the motors are connected. So here, movement motors equals motor pair C and D. Lifting arm equals motor. Which motor is the lifting arm? E. And then finally the distance sensor equals distance sensor. Distance sensor is on F. Okay. All right. And then let's connect our robot up. So we go into connect. Oh, make sure we turn on our robot first. The Bluetooth button. Bluetooth. Did I hit the wrong one? There we go. Okay, so we have our robot connected. C, D, E, F. That's correct. Okay, so for our first example of working with conditionals, let's do a simple one. Up here where we are creating our objects, let's define a new variable, x equals 5. So here, to do an if statement, conditional, we use the keyword if, just like in Scratch. So if x is less than 10. So the less than symbol is the shift comma key. It's right next to the M key. If x is less than 10, then we do something. Then is a colon. Right? So that's the shift semicolon right next to the L. If x is less than 10, then we're going to go hub.lightMatrix.write x is less than 10. Else, so you got to make sure you outdent back into the same level as the if. Else, hub.lightMatrix.write x not less than 10. Okay, so because we set x as 5, then it should print the first item out, which is that x is less than 10. Okay, so if I run the code, see, x is less than 10. Cool. So very simple stuff so far. So if I changed x, if x is equal to 20, then it would print the thing below. See, x not less than 10. Cool. So that's how we do a very simple comparison. So we'll go through all the different types of comparison symbols as well. So we can also do this. Other comparison operators. So that's, oops. This is less than, this is more than, and this is less than or equal to. Make sure you actually type these out, because it builds muscle memory and it also makes it easier for you to understand later. These comments, even though Python doesn't need them in order to run, these are great for reminding you later on if you ever get stuck and you need to remember what does what. Less than or equal to. And the more than sign and equal sign is more than or equal to. Now, there is a trick here. How do I check if something is equal to something? Well, let's have a test. So let's comment this out. To check if something is equal to something, we would say if x is equal to, say, 50. Then we will say, I'll explain why we have two equal signs, okay? So hub.lightMatrix.write x equals 50. Else hub.lightMatrix.write x not equal 50. Okay. So why do we have two equal signs? We have two equal signs because we already have a command for one equal sign. Right? Does that make sense? Python already knows what the equal sign means. You see up the top here how we have x equals 20? That is one equal sign. So when we have one equal sign, we're telling Python to equate something to something else. But if we are checking if something is equal to something, we can't use the same symbol, because otherwise Python will go crazy and doesn't understand. So that's why we have to have two equal signs to check if something is equal to something. So here I'll just comment, if we check for something to be equal, we need two equal signs. Okay, very important. A lot of people get caught out by this. So that's how you do it. So right now, x is equal to 20, so it's going to print out, hopefully, x is not equal to 15. X not equal to 15. Cool? Excellent. So so that is why we have two equal signs when we are comparing something. We can also combine different operators together. Just like in Scratch, we can use and or. And not as well. So here, to combine operators. So you can say if x is less than 20 and x is more than 10, then we'll say hub.lightMatrix.write x is between 10 and 20. Else we'll just write out false. Okay, so this is how we combine operators. And x is equal to 20 at the moment. So it is not less than 20, it is equal to 20. So it should say false right now. Yep, so typed out false. But if I changed x to be equal to, say, 15, x is between 10 and 20. Okay, so that's how we combine different operators. There's also a special one for not. Okay, so I'll list them all down. Whoops. Other operators. So and is equal to and, or is equal to or, and exclamation mark is equal to not. So if I wanted to check if x is not equal to something, I'll do it like this. I'll go, if x is not equal to 10, hub.lightMatrix.write x not 10. Okay. Else hub.lightMatrix.write x is equal to 10. So if you've been listening, then you'd be wondering why this is a little bit strange. Why is it that when we're saying not equal to 10, we can use one equal sign when we're comparing something? Well, that's because when you put a not in front of it, Python will automatically know that you're comparing something. And that's why we don't need the two equal signs when we're checking for not equal to. We only need the two equal signs if we are checking if something is equal to something else. Okay? So here, if it's not equal to 10, so right now it's 15, so it should print out x is not 10. X is not 10. Okay? Alright. You've sat through all of this. Well done. You have learned most of the stuff to do with conditionals now. And now we're going to apply it to make something fun. We're going to turn you into a Jedi. So a Jedi is a Star Wars character who can move things with his mind. We're going to make it so that our robot is going to get pushed away by our hand and also pulled by our hand if we move our hand away, so that we can have a little bit of a force push with our robot. So I'll show you how to do that. And last lesson we learned how to do a forever loop. So I'll show you how that applies here. All right, so let's. So now we go for our Jedi challenge. So we need to constantly check the distance in front of our distance sensor. So in order to do that, we have a while loop, a forever loop. So while true. While true, what are we going to check? Well, if we'll check if distance sensor dot get distance centimeters, open close bracket, because this is a function that gets the distance that's in front of the sensor in centimeters. If the distance is more than 20, if it's more than 20 centimeters, then so colon, then we're going to move forward. So movement motors dot get set default speed to 20. So we're moving forward. Dot start. Okay. And then you know how in Scratch you can nest if statements inside the if else statements. Well, we can do that here. So if the distance is more than 20, else if. So instead of writing else if, we write in Python elif. Elif distance sensor dot get distance centimeters is less than 20. Then we do the opposite. We do this thing, we're moving backwards. Okay, so to move backwards, you go negative 20 for our default speed. Else, then we stop movement motors. Dot stop. Okay, so this is all you need for your Jedi challenge. So what we're checking is we're having a forever loop, and then if it is further than 20 centimeters, we're moving forward. If it's closer than 20 centimeters, we move back, and then if we are neither, then we'll stop the motors. Okay, let's try it out. Okay, I hope you enjoyed the lesson today. I can't wait to teach you the next one. If you liked the video, then please like and subscribe. I'll see you again next time. Bye-bye.